Okay, today we're going to talk about the graphs of polynomial functions. A couple things to go back over that hopefully you learned in Algebra 2. The end behavior is based on the degree and the sign of the leading coefficient. LC is my abbreviation for leading coefficient. The right side of the graph rises when the leading coefficient is positive, and it falls when the leading coefficient is negative. Even functions, the ends go in the same direction. They're either both up or both down. And odd functions, the ends go in the opposite direction, one up, one down, either side. Now remember, this is even degree and odd degree, not even and odd functions. The number of solutions or roots is based on the degree of the polynomial. Sometimes they're all real and sometimes they're imaginary, but I know the number of solutions each polynomial is going to have. And the maximum number of turns, so the max number I can estimate would be the degree minus 1. Okay, now to put that in play. The first is show me the degree. That's a degree of 5. So that tells me that the number of solutions is 5. The estimated number of turns would be 5 minus 1, so that is 4. So now when I go and do my end behavior, I see that I have a negative odd. So a negative odd tells me the right-hand side, since it's negative, is going to go down. Let me get the right pen. Is going to go down, so that means the left-hand side is going to go up because odd is opposite. So the top is the left, so that's positive infinity. The bottom is the right, so that's negative infinity. So I kind of think about the ends before I do my end behavior. Okay, so the next one is an even. It is a degree of 6. We'll start off there. So that tells me that there are 6 solutions. Then 6 minus 1 is 5. That's the max number of turns. Since it's even and positive, that tells me that the right-hand side is up. And since it's even, they're both going the same way. So as x goes to the left, it's going to positive infinity. And as x goes to the right, that's positive infinity. Okay, so this last one is a degree of 4. So that tells me that there are 4 solutions. So 4 minus 1 is 3 maximum turns. I also see that my leading coefficient is negative even. So the right-hand side is down because of negative, and because they're even, they're going the same way. So as x goes to negative infinity, y goes to negative infinity. As x goes to infinity, y is also going to go to negative infinity. Okay, a couple other things. When we're graphing, we're going to find all the real roots and plot those x-intercepts on the x-axis. We're going to think about the end behavior. If there's a y-intercept, factored form, we're going to evaluate everything x at 0. Standard form, it's the constant term. And then some other things we have to remember. Multiplicity means how many of a solution there are. So multiplicity of 1, the graph is going to cross the x-axis. An even multiplicity, like 2 of the same answer, 3 of the same answer, 2 of the same answer, 4 of the same answer, this is going to bounce. And I'll show you when we get there what a bounce looks like. And then an odd multiplicity, that's not 1, because 1's going to cross, like 3 or 5, it kind of wiggles through. So you got to kind of look for that. And that's the way I describe it. Okay, I'm going to start off, and I always go and determine my real roots. This is in factored form, so I take each factor and solve it equal to 0. And so x is 0, x is going to equal to positive 4, and x is going to equal to negative 7. So I'm going to estimate negative 7 here. This is 0. And then positive 4, notice it's an estimate. I'm not really doing anything but estimating because I'm sketching this graph. So the next thing I want to do is determine the end behavior. So I'm going to count the factors in the solutions. There are 3, so this is a degree of 3, which makes it an odd degree. My leading coefficient is positive, so that tells me my right-hand side is up, which will make my left-hand side down. So those are the things I'm thinking about. And I already have a point on the x and the y axis at 0, so there is no y-intercept. I don't need to find it because it's already there. So now I'm going to connect the dots. My end behavior tells me I'm going to start below the -7. I'm going to go up and cross the 0 and turn back around and cross the 4 because these are all single multiplicities of 1. So I start below, I cross, and I cross. And that is an estimate of how it looks. Okay, so now this one I'm going to do the same thing. I'm going to set each factor equal to 0 and solve it. So this x is equal to 0, this x is equal to -3, and this x is equal to -5. So I have a -5, a -3, and a 0. Then I'm going to go through and I'm going to kind of pay attention. This is to the squared, so that says at -3, I am going to bounce off -3. And I usually make note. I put a line, other people do other things, but I just put a line that reminds me I'm bouncing. Now I'm going to look, and I have a degree of 4, because this is 1, 2, 3, 4. So it's an even and negative. So since it's even and negative, the right-hand side is down, so the left-hand side is down. So it says I'm going to start below the -5. I'm going to go up, turn, bounce off the 3, go up, turn, and go through the 0. So I'm going to start below, I'm going to bounce, and come back down. So that's the way that graph, I'm going to estimate the way it looks. Okay, so I have a polynomial that each one of them have a different multiplicity. I have a multiplicity of 3 here and a multiplicity of 2 here. That is a degree of 5 and a negative leading coefficient. So that says my right-hand side is down. Since I'm odd, my left-hand side is up. Hopefully we can see now that if my factor is x plus 3, my root is -3. If my factor is x minus 4, my root is 4. So I have a -3 here, a 4 here. I am going to wiggle through the 3 and bounce at the 4. This y-intercept is going to be large. I'm not going to worry about it, but it's going to be down here because it's -1 times 27 times 16. And since we're estimating what these look like, I don't really need to worry about so much about that. So this says I'm going to start above the x-axis. I'm going to wiggle through the 3, and then I'm going to turn back and bounce off the 4. So I'm going to come up here, I'm going to wiggle through the 3 and bounce off the 4. And that's horrible over there at the bounce, but that's okay. Okay, so I've got one that is in standard form. It's not in factored form. But there's a couple of things. Remember, this is the y-intercept. It's way up here at 400, which we're going to estimate when we graph this. When I graph this or factor this, I'm going to factor by grouping because it's 4 terms. These first 2 terms have an x to the 4 in common. Leaves me x squared minus 25. Bring down that negative, and I can divide these each by 16, which gives me positive x squared minus 25. Remember, we do it right if our parentheses have the same. So I have x to the 4th minus 16, x squared minus 25. Well, x to the 4th minus 16 is a difference of squares. Remember, that's 1 plus 1 minus, so x squared plus 4, x squared minus 4. X squared minus 25 is also a difference of squares, but that's x plus 5, x minus 5. Well, this one right here has two imaginary solutions. So I have solutions, but I can't graph them because when they're imaginary, they don't show up on the graph. So I've got to continue to graph this x squared minus 4, and that becomes x plus 2, x minus 2. So now I look at these 4 factors, and my roots are going to be x, oh, wrong pen. My roots are going to be x equals negative 5, x equals 5, x equals negative 2, x equals positive 2. This is an even positive, so they're both going up. So I'm going to put on negative 5, negative 2, 2, and 5. These are all singles, so I'm going to cross. I'm going to start at the top, cross, cross, go up to that 400, cross, cross. So I'm going to cross, cross, up, cross, cross. Now, we can figure out mathematically how long these are. They are even. I just, that doesn't matter because we're sketching. But that is what that's going to look like, and that is kind of how we're going to graph. If you aren't using a calculator, this is the best way to get it on because I'm not as concerned about the loops at this moment.